Hi everybody, I'm Zana Jardine, Head of Education for SafMed, and I'm going to take you through today's webinar. This is the third webinar in our Insights series that we're running at the moment, and it's brought to you compliments of SafMed. SafMed, of course, has been your solutions partner for the last 30 years and have a range of products available for you, both CSSD and for the operating room. This is the third webinar, as I said, today being the 19th of May, and the focus will be on cleaning brushes and droplet dispersal. Next week being the fourth webinar, which is the 26th of May, we'll have a bit more of a surgical focus. We'll look at latest guidelines by the Association of Operating Room Nurses, changes they've made, contamination in the sterile field, a little bit more about waste management. Some of those changes from the AORN are actually CSSD related, and waste management, of course, is a topic dear both to theatre and to CSSD staff. So although there's a surgical type focus, it'll be very relevant to all of us, IPC, CSSD, and operating room staff as well. In today's session, we will cover the topics of cleaning brushes, brush techniques, splashes in the CSSD, droplet dispersal in the CSSD, and we'll finish off with the topic immediate use steam sterilization. I'd like to thank everybody from SafMed who have participated or added value to these presentations. This, of course, is all a variety of teamwork. It's no one person putting this work together. I'm going to dig straight in because we have quite a lot of information to cover today. If you've done the CSSD Foundation course, you may be familiar with the slide that talks to cleaning brushes. And of course, what are cleaning brushes? Well, quite simply, they're implements that have bristles that are made of flexible materials, often fixed in a handle to scrub and clean devices with. We also know that cleaning brushes themselves can become contaminated with patient debris and that they could potentially transmit infection, and that we should really make sure we manage them carefully and that we check and clean and disinfect them accordingly. Cleaning brushes can be divided or categorized into 6 different types: general cleaning brushes, toothbrush style, burr cleaning, lumen cleaning, valve cleaning, and those that you can use for cleaning reamers. I recently attended this really awesome, I thought it was awesome, lecture about instrument cleaning brushes. It was hosted on Key Surgical's website, and if you wish to go view this, it's an on-demand course. You can do so. It's at no cost. All you need to do is Google Key Surgical Online Education, create an account, password for yourself, and go on and have a look at a variety of training courses they have available. And this particular one we'll cover now is all about instrument cleaning brushes, manual cleaning, why, how, and what if. The course began with some understanding around terminology relating to brushes, important point, of course, if we're talking about them. It started off by describing what is a bristle, the part of the brush that does the work. What is the handle, the part of the brush that holds the bristles in place. Then some new words I had not heard before: abrasion resistance, the ability of the bristle material to actually resist wear and tear. Bristle bend recovery, so the ability of the bristle material to return back to its original shape. And non-shedding, the measure of the material's resistance in terms of splitting or breaking or shredding or coming off the actual brush itself. All key important elements. Then I learned a little bit more about brush bristle material types. And brush bristles can be made of a variety of different products, and they include nylon, polypropylene, brass, and stainless steel. I had not heard of polypropylene-based brushes before, so this was some new information for me. They went on to describe the pros and cons of each different type of material and what it's good for and what it isn't good for and its value add, and we will go into more detail as we go along. Firstly, nylon material brushes or bristles. Nylon's a very tough material. It's abrasion resistant. It's got good bristle bend recovery. But the nice thing about it is it really doesn't scratch most types of surfaces unless you've got a really, really soft metal or a really soft surface. Nylon is the softest brush bristle available at the moment. Polypropylene seems a little bit more interesting in that it's inert to oils and chemicals and it doesn't absorb moisture. I've not really seen anybody use polypropylene brushes yet, so it'll be interesting to learn more about those as we go along in the future. Brass-based brushes, so that's the softest metal fiber-based bristle that you can get. They won't generate sparks, which is a good thing, and they do have poor bristle bend recovery because it's so soft. Stainless steel has excellent bend recovery, but it's really for aggressive cleaning, so you need to be very cautious if ever you're using stainless steel. And even more importantly, don't ever brush anything that's insulated or coated with stainless steel based brushes. Antimicrobial coatings or antimicrobial based brushes. Again, an interesting point I've not learned anything about before. Bristles, normally those of nylon, can be made to be antimicrobial. So either you can make the brush out of a material that's already been treated, or you make the brush and then you treat the bristles after the fact with antimicrobial materials. That does not impact the form or function or the brush's cleaning abilities. It doesn't make it better or a better cleaning brush. But what it does do is prevent the growth of bacteria, mold, and yeast on the surfaces of the bristle, which of course is going to be an advantage. If you haven't cleaned off the patient debris, though, it's not really going to help you much because there's so much patient debris. But hopefully it can prevent the growth of mold and yeast if you're managing the bristles correctly. The advantage of these antimicrobial materials in brushes is that it slows down the breakdown of the bristle material, which hopefully can prolong the useful life of that particular brush. Right, brush selection, and it's quite obvious that one size does not fit all when it comes to brushes. And when we are selecting a brush, the things we need to take into account is firstly that the proper brush selection is actually critical to the efficacy of the cleaning. I think that makes logical sense. It's critical to follow the manufacturer's instructions for use. So the device manufacturer or the instrument manufacturer will specify what type of brush bristle you can use. Of course, correct to choose the right type of materials and the correct shape as well as the correct diameter, especially if you're doing lumen cleaning. And we'll go into more detail on that now. The pictures on the screen, I think, tell a good story. You want efficient and effective cleaning, and both of those, for that, you need maximum bristle tip contact. And you need the proper type of bristle, of course, as we already said, for the type of surface being cleaned. If you look at the images on the screen, top one being too big, you can see how that big brush is being forced into that lumen. You can see in the middle image that that brush is too small and it's not touching the sides. And the third picture at the bottom is a brush that is applicable for the lumen size. In the webinar, they went on to talk about features of the brushes and what the pros and cons are around that and the risks relating to certain things. If the diameter of the brush is too large, and they put in the guidelines that you shouldn't use a brush that is more than 1/8 of an inch larger than the channel size that you're cleaning, which means you need to know the channel size. If you use one that's too big, the bristles are going to lay up against the wall and actually don't give you friction. So not very effective cleaning at all. Then, of course, there's the difficulty of the fact that the brush could get stuck and that the brush could damage the lumen that you're busy trying to clean. Too small, we know that's pretty obvious, that the bristles won't actually touch the walls and you won't get an effective scrubbing action. Brush length also matters. They advocate, or at least I learned in the webinar, that your brush should be at least 2 inches longer than the channel being cleaned. If it's not, you're unable to get the dirt all the way through the lumen. Also, you're not going to clean the entire length of the channel that, of course, you're trying to clean. brush handles. As you all know, you can get brush handles that are looped and non-looped, and both have pros and cons. Non-looped ends, sometimes you have a little less sturdiness to it. The brush can maybe get lodged, and with repeated cleaning action, you can maybe get kinks in the brush. Although a non-looped end allows you to pull the brush through all the way, through the lumen all the way, of course. A looped end could perhaps prevent the brush from getting stuck. Of course, assuming the brush is long enough. It allows the brush to be hung up, which is a very important feature. And of course, the other issue is that it could be that it doesn't reach the full length of the lumen if there's a loop on the end and your brush that you're using is too short. Multitude of tips to the brushes, and what we showed an image of over there is the fan tip brush. And the fan tip brush, as you can see, the bristles are all the way onto the nose of the brush as well, and they're really good for cleaning closed-end channels, and they are quite protective on the end, and very useful for closed lumens because they can be very difficult to clean. The next thing I learned about was the brush bristle area length, so the amount of bristle that there is to clean the area that you're cleaning, and it needs to be appropriate. So, cleaning a toothbrush or using a toothbrush to clean a really large instrument is going to take you too long to do that, and you're not going to get a really good, effective clean. If your bristle is too long and the actual bristles extend outside of the channel while you're busy doing that cleaning motion, you're going to get a splatter spray scenario, and that could be at risk for you. So again, too long is of concern, and too short, you may not get effective cleaning. And we spoke about this already, the material that the brush is made of, that the bristles are made of, must be in accordance with what's instructed by the manufacturer's instructions for use. Too soft and you won't get an effective clean. Too hard or too abrasive, you will damage the actual instrument. Very logical, we all know that. During use, how do you manage your cleaning brushes? So if you're busy cleaning something manually, which of course is what you'll be doing whilst using these brushes, is the importance of cleaning the actual brush end in your detergent water solution. So every time it comes out the lumen, you want to rinse it off before you put it back in the instrument, else you'll just resoil or recontaminate the area. After use, of course, important to rinse off all the gross soils properly in a deep sink. This prevents spraying of soils into the air. You want to do it under the water line. You want to follow the instructions from use from the person that you bought the brush from. If you bought the brushes from Clicks or Pick and Pay, then there will be no instructions for use because they weren't designed for medical devices. If you're buying a brush designed for a medical device, it will of course come with a set of instructions for use. And they will include, I'm sure, cleaning manually using an enzymatic detergent, agitating under the water, repeating the process until the bristles are free of soil, and hanging them up afterwards to dry. A nice feature of medical device brushes is that you can often actually put them in an automated washer disinfector, which is a concept you can do at the end of the day, perhaps. Put all your brushes into the washer, let them wash, let them be disinfected and dried. It could be a very useful process. When do you replace them? Well, as soon as they start wearing and tearing, of course, but how much wear and tear is always a debate. How long can I keep it lasting for? You're going to inspect for wear, you're going to inspect for fraying. We spoke about shedding already. You're going to look for damage, you're going to look for kinks and bends in the handle because that could possibly lead to damage to an instrument. What are the risks if you don't replace your brushes frequently? Of course, that you don't clean properly and you get this terrible buildup of biofilm in soils. There's also the possibility of device damage. You could leave a foreign body inside the lumen because you didn't clean properly, or a piece of bristle could be breaking off and you end up with bristle in the lumens or in channels. If you have a look at the image on the right, that's a borescope. Somebody's used a borescope to take an image inside a lumen, and there's a piece of bristle left in that particular item. Of course, the other risk is that if your brush is not working correctly and it's damaged, it's going to take you so much longer to clean the device. Another interesting paper published, this one in the Association of Operating Room Nurses Journal, and was published in 2020. And it focused on the effect of brush motion and rinsing when cleaning cannulated devices manually. Quite a fascinating paper, actually. So the researchers began with 21 clear catheters that were a 16 French lumen. Of them, 3 of them were left untouched. Then the 18 rest of them were all inoculated with a commercial swelling test. 3 of them were not cleaned at all. They were the positive control. The 3 that were not inoculated were the negative control, and that left 15 brushes to use for the experiments. So they then cleaned the 15 brushes using 5 different cleaning methodologies. And the whole idea at the end of the day was to establish which method of cleaning, which technique was the most effective. So they began with group 1, where they cleaned the inoculated clear catheters only by using high pressure water. In group 2, they cleaned by using a back and forth cleaning motion, but without rinsing the brush. Group 3, they did the back and forth cleaning motion, but they rinsed the brush between each back and forth motion. With 4, they brushed with a helical spinning type motion, so more of a spin, with no rinsing. And in group 5, they brushed with the helical motion and rinsing in between, rinsing the brush tip in between. What was the most effective method? Number 5 was the most effective method they found. But what they also noted that was, although number 5 was the best cleaning method, it was the most time consuming. They said that rinsing with high pressure alone was actually more effective than brushing, the brushing back and forth, that didn't rinse. In fact, just using water was more effective than that kind of brushing. So their conclusions were that rinsing the brush was really important. So rinsing the brush between cleaning motions is a very important concept. They also noted in the study that a combination of brushing and flushing was very effective, and many ultrasonic cleaners, as you know, alternate sonics and lumen flush is a very similar principle. An extract from the published paper over there. And the picture on the right is that of a Yankau sucker, as you know, with the rose tip removed. That was all part of my master's study, where I was looking for what was inside the brushes or inside the lumens of suction cannulas and whether or not we were cleaning them properly. They then said in the published paper, here's the extract, that personnel can use ultrasonic cleaning with a lumen connector and an intermittent flow instead of manual cleaning where there's evidence of sufficient cavitation. So that's the vibration movement, of course. But the use of ultrasonic washers and washer disinfectors does not eliminate the need for brushing before automated cleaning, because the reduction of bioburden makes automated cleaning more efficient. So ideally, we should be taking our cannulated instruments, putting them through an ultrasonic washer, and then but doing a manual process as well, and putting them through the washer disinfector. And that way, we'll make 100% sure we're cleaning our instruments correctly. Key takeaways from this paper were when performing manual cleaning of cannulated medical devices, that personnel may find that it's difficult to remove organic and inorganic debris that we already know. The results of the study indicate that brush rinsing during brushing increases the cleaning efficacy, and that when manual brushing is used, that the department members should use the appropriate size brush for the lumen, replace worn and non-functional brushes. In addition, they should rinse the brushes during the cleaning process. All good information. Right, so that was everything I learned from that particular webinar on from the Key Surgical website. There was a lot more detail actually in that webinar, so please feel free if you have time and capacity to go and listen to the full webinar. This is a paper published and printed in the Central Sterilization Journal, the German journal that we've spoken to before. So again, don't be too confused when I'm using direct quotes because the English is not spectacular. And in this, they looked at trying to protect staff from liquid splashes on the dirty side of the CCSD when cleaning manually, and they also refer to when cleaning with a steam cleaner. So if I understood correctly and looked at the image, it was a particular device that did some form of steam cleaning that they use in Germany, and they were concerned about how to protect the staff. What they did was they used a fluorescent solution. So they put the solution in the sink and they cleaned instruments using it, and then you put on a UV light, and then you can see the fluorescence to see where the splash went to. They did find that they couldn't visualize properly on all types of PPE, and some it showed up quite easily and others it didn't. But if you could take a look at some images over here that I've put in, you can see the amount of splash onto the mask. They also included this image over here on the left. I thought it was quite interesting that on the non-dominant hand, it gave you a 13% rating of splash, but on the dominant hand, only 13%, and the non-dominant hand, 22%. So obviously the non-dominant hand was more contaminated. I thought that was quite interesting. As you can see from this, the splashes seem to go pretty well everywhere. They say that the neck is highly exposed to splashes. That's a direct quote. So I guess that's what they view to be risk areas. Areas of concern, the neckline, the arms, the hair, and the face. So that's why it always worries me when we resort to just using aprons. I'm not so sure that we're doing a good enough job of protecting ourselves if we are just using aprons only. So I think we really need to think carefully about how we are protecting ourselves on the dirty side of the CSSD. The one thing I think that has been good, sad but true, is that COVID has really and truly made us a lot more aware of the importance of our PPE, especially on the dirty side of the CSSD. Okay, staying with the topic of splashes and droplet and aerolization and dirty side of CSSD, I also attended a webinar by Corrie Offstate. Corrie Offstate is a researcher. I think her background is that of a microbiologist. She's really well published, especially in the American Journal of Infection Control. She was very kind and gave me some guidance when I was doing my master's. And Corrie Offstate's webinars are normally paid for. And at the moment, sort of since COVID, they have actually made them available for free. There are a few very much IPC-related webinars that she's hosting on her channel. You can find them if you look there for Offstate Elevate. I think it's compartners or something of the sort. I'm sure you'll find the website, create an account for yourself. It says over there, kind of it looks like you think you're going to pay for it, but just click on it. Don't worry, you won't. And eventually you'll get to be able to do some of the webinars if you so choose. This one was fascinating. I thought this was all about, as you saw, making a splash, contaminated droplet dispersal in the decontamination areas. Just covering a few parts of what was covered in this webinar here today. It was really interesting. She begins by discussing the risks associated with splashes, and she gave some examples of endoscopists and urologists with splashes in their eye, and examples of putting chemicals and where people had in fact got chemicals in their eye. I don't know about you, but I've actually had quite a few splashes in my eye over the years. Certainly when holding a limb, when somebody's cleaning the leg, for example. So I've definitely had betadine and Hebitan and alcohol and some cleaning solutions and horrible things in my eyes before because I wasn't being wise and wasn't wearing my PPE as I should have been. So Corrie goes on to put quotes in from various guidelines, ESG GE is the European Society of Gastroenterologists, and AME, of course, the American group, saying that splashing should be avoided throughout the entire process of cleaning, and you want to avoid contact with infectious materials, detergents, and disinfectants. And of course, don't forget, we want to avoid contaminating the environment and the sink and the surfaces next to us where we are cleaning. In the paper, she talks a lot about previous research and other IPC research that looks at sinks. And, you know, sinks in wards, sinks in ICU settings, and there's a lot of talk around distribution of contamination because of sinks and drains and horrible things in wards and ICUs. And she talks about how difficult it can be to clean sinks. And somewhere in the US, I got a little bit confused. They had a reference to potential splash and that things needed to be stored 3 feet away from the basin, because that's how far the splash can reach. And she wanted to do some research focused in the dirty side of the sea system on splashing. And of course, with splashing, or potentially with splashing, could be the fact that you have contaminated droplets and it's contaminated droplet dispersal. She also tried using the fluorescent marker as the previous researchers had done from Germany, but she believed it not to be the most effective. It didn't give her a good enough view of what was happening from a splash point of view. So instead, she found this particular product, which I haven't seen available locally, but I know it is available from a particular company in the US by the looks of it. And it's scope indicator drying paper. So you would hover your the end of your scope that you've cleaned over there, push through some air, and it changes color if there's still water inside the scope. Actually sounds like an interesting concept. So what was the goal of her research? She wanted to know what reprocessing activities in the CSST will generate splashes. Where do the droplets go? How far do they travel, and do they travel further than the 3 feet? Does scrubbing under the waterline make a difference? And we've been lecturing that forever, but she wanted to know, does it really make a difference? And how well does PPE actually prevent exposure during reprocessing? And which parts of the PPE get contaminated? And even if you are wearing PPE, do you get contaminated? So I haven't covered everything in our webinar today. But there are some interesting statistics and really nice visuals of where all you can get splashed, and it is literally head to toe. This is how she, oh wait, I'm one slide ahead of myself, apologies. So here was what she was targeting. Will these activities generate splash? Filling an empty sink, placing a uterinoscope in water, dropping a uterinoscope in water, brushing a lumen underwater, brushing a lumen above water, spraying a basin while rinsing, using an air gun for drying, and using an ultrasonic bath or sink. This was the setup. So they took this that chemical indicator paper and they put it all over the CSSD environment, on the behind the sinks, to the sides of the sinks, to the left, to the right, to try and see how far the splashes would generate. Then they asked an individual, who set up the individual who was now going to clean something manually, and they put the strips all over their body, all over their PPE, above the arms, around the arms, in front of the apron, etc. She actually also did one on gloves, and wearing of gloves under the cuff of the gown, wearing of gloves over the cuff of the gown, to see the effect at the end of the day and how far people got contaminated or the potential splash went. And thankfully, she proved very, very well, I think, if you look at these two images, that brushing under the water generates far less splash than brushing above the water does. You can see the droplets all over the individual's chemical indicator attached to her PPE. In the presentation, she also talks about the engineering controls, because, PPE is the last resort. in the CSSD, yes, we are going to be exposed to a variety of things. And one of the things we need to do is to wear our PPE, but there is more than that just to worry about. And all of the IPC sisters will be very familiar with the concept of all the various risk strategies and what it is you need to put into place, engineering controls, and then, of course, wearing PPE. And she talks to those as well in her webinar. So, what generated visual droplets or not? Filling the sink, definitely. Spraying the sink in the basin, yes. Dropping a scope in, placing a scope in, brushing under the water, brushing above the water, all generated splash, some to a lesser and greater degree, of course. Running an ultrasonic sink, no, didn't generate splash. That was quite good. So if we are using air guns, for example, we also need to figure out that we use them carefully and correctly. At the end of the day, the key takeaway points from the research that she had were as follows: that during reprocessing, we are at risk of exposure to infectious materials and hazardous chemicals. Both. We need to remember both things here. That droplets from splashes generated during the procedures and the routine reprocessing can travel more than 5 feet. And that it got onto the personnel working in the splash zone, literally from head to toe. She had some images of splashes even on people's feet. So it really does spread far, and we really have to take that into cognizance. And that also talks to how we take off our PPE, and how we wash our hands and how we decontaminate ourselves after we've actually been washing things and been exposed to various splashes. She said that wearing PPE plays a critical role in reducing exposure, that PPE must be combined with other engineering solutions to try to prevent infection and injury, like the design of the CSSD, the flow of the CSSD, the design of the department, the air conditioning. She spoke to those engineering factors, and that solutions require active involvement from a multitude of stakeholders. So it's not just us putting on our PPE, it's about how we manage the entire situation. The next steps that Offstate and team will be taking is that she's now going to write a manuscript for publication. I'm not sure if she'll write it completely on what she's done now, if that was just her pilot, and she'll do additional research around that, but that is their intention, to now write a manuscript for publication, and that will be very interesting to see. But it was really nice to hear about this before it reaches publication stage and know that somebody is working on this. She wants to urge others to conduct more research and share their findings, and she was going to find ways in the US to reach out to professional associations to try and improve the guidelines around splashing and around managing aerolization of droplets in the CSSD environment. So that's her goal forward, and of course the whole idea is to protect us and to protect the patient. Right, so far, remember we've spoken about cleaning brushes, different types of cleaning brushes, using the correct cleaning brush for the right job, making sure we got the right size, the right shape, the right bristle type. We've spoken a lot about covering ourselves, protecting ourselves in the CSSD. We've spoken a lot about splashes. Now we're going to move on to chat about another published paper about immediate use steam sterilization. So this was published in the American Journal of Infection Control, also in 2020, and it was a summary of the poster abstracts from the APIC, the American Infection Control Congress, and the individual who wrote this, to the best of my knowledge, is an IPC nurse. So the title of the publication is Reduction of Immediate Use Steam Sterilization via Education and Transparency. And one of the quotes in the paper that stood out, of course, is IUSS is less effective than standard sterilization processes. IUSS, or immediate use steam sterilization, of course we used to know it as flash, may increase the risk of surgical site infections. And the entire goal of this paper was to identify their current use in their hospital setting and to come up with some improvement strategies and to see if that could actually reduce the use of immediate use steam sterilization in their facility. Those of you that have done the CSSD course would have seen this slide, and this slide talks to the difference between immediate use steam sterilization versus terminal sterilization. So, of course, terminal sterilization is where instruments are cleaned, wrapped, sterilized, and stored for later use. They still need to be cleaned, they must be dried, they must be inspected as normal. It is the preferred method of sterilization, and devices and instruments are wrapped or put in some form of sterile barrier system like a container and sterilized. Immediate use steam sterilization used to be known as flash, where instruments are cleaned, not wrapped, sterilized, and used immediately after sterilization. Remember, they still need to be cleaned, they still need to be dried, they still need to be inspected, they still need to undergo all of those processes before you use them. An immediate use steam sterilization should only be performed under emergency conditions and only if it is clearly instructed in that device's instructions for use that it can go through an immediate use steam sterilization cycle. So items, of course, are not put in a sterile barrier, they are not wrapped, they are used immediately after sterilization. What are the nuances to immediate steam sterilization? We remind ourselves of that again. You have to first consult the manufacturer's instructions for use of that device. Some batteries, for example, it'll clearly recommend that they can go through a USS or flash cycle. If you are using it, you need a logbook and you have to record who the actual devices were used on. You must trace it to the patient. You may not put anything implantable inside of an immediate use steam sterilization cycle, and I really would not do anything orthopedic, instruments, devices in a flash cycle. Again, only if it's included in the manufacturer's instructions for use. You should not be putting any single-use instruments through a steam sterilization, immediate use steam sterilization, and of course any device that may have been potentially exposed to Creutzfeldt-Jacobs disease must not be flashed. Here is an example of manufacturer's instructions for use kindly provided by Carl Storz for us to use for our webinar. And as you can see, for example, in this particular set of instructions, it says over there, do not flash, sterilize any Carl Storz telescopes, light carriers, or light deflectors, for example. So it will clearly say that, which is really good. So in this research, the IPC sister did a baseline surveillance, obviously, to see how often they use immediate use steam sterilization as a norm in their hospital setting. Then they put together a series of targeted approaches and these strategies now to try and reduce the amount of immediate use steam sterilization. So they had targeted educated sessions for the surgeons and the operating room nurses. Often it's the operating room nurse and the surgeon who drive the use or the need for immediate use steam sterilization. And sometimes it's just because of poor discussion or poor communication or poor trust between the two departments. They wanted to focus on the appropriate use of immediate use steam sterilization. So if you did have to use it, that it was used correctly. Of course, to do that, one of the important things is to assess all of your inventory, because you don't want to be flashing because you don't have enough instruments. That's not the real correct reason for using immediate use steam sterilization. So they ruled that out and overcome those issues. And then the next thing they put into place, which I think is absolutely awesome, is that if there was an insistence, in this case they said by the surgeon, but I would do it for the theatre nurse as well, If somebody comes into this and says we have to use immediate use stem sterilization, they have to sign a document to acknowledge the risk, and they have to acknowledge the risk that the benefits of now putting it through the flush cycle will outweigh the risks, and only then were they allowed to proceed. Was this effective? Absolutely. So they were able, I'm not 100% sure how they did this calculation, but as you can see, they reduced the use of immediate use steam sterilization from 0.28% to 0.11%. And then they also did some form of statistics around contaminated during procedure, and that had been reduced from 30% to 19%. And they went through a phase where 9 out of 16 months, there was no need to use immediate use steam sterilization. So their conclusions were quite simple, that with focused infrastructure and good transparency of how you're using immediate use steam sterilization, you can minimize the use thereof, if not even not use it at all. And I'm aware of many hospitals that in fact have removed flash sterilizers and don't allow that facility at all. Coming to our conclusions and wrapping up for today's session. We've spoken about cleaning brushes. We've understood about the different bristle, it's not easy to say that, bristle materials. We've learned about the correct size and diameter of brushes and the pros and cons and the risks of using the incorrect things. We've spoken about brush technique and the importance of rinsing the tip of the brush all of the time. We've spoken about splashing in CSSD. Remember, we've spoken a lot about droplet dispersal and how far the droplets do carry. And we finished off with immediate use steam sterilization. I hope you found today's presentation interesting.